Hello, it's Mrs. Green. This lesson is on multiplying and dividing decimals. So we're doing two topics in one lesson because we are getting faster with our operations. So multiplying and dividing usually go together. They're inverse of each other. They undo each other. And now we're working with a type of number that's not fractions. It's not integers. It's now decimals. First, you need to put down your prior knowledge. Prior knowledge, my little graphic here has some of the rules of multiplying and dividing decimals. I'll go through the key information on the next couple of slides once you've put down your prior knowledge. So your key information for multiplying, you're going to have two subtopics. One is multiplying decimals and one is dividing decimals, as the topic implies. So multiplying decimals is first. If you want to, as you type in or write down your definition here, your rule, if you want to underline multiplying decimals or write multiplying decimals and then a dash, so that you know this part is the topic about the multiplying. And you can copy this down. I've typed it out. Multiplying decimals, you do that as you would do a whole number. Same rules apply. And then you figure out where to place the decimal point. So write them vertically, and then we'll figure out where to put the decimal point. The way you figure that out is the number of decimal places in the product, the answer, ends up being the total of all the decimal places in all the factors. So the factors are the numbers that you multiplied together to get the product. And so if that's two numbers, then you would just count up the decimal places, add them together, total them, and that would be the number in your product. So here it is in words. And I also want you to write numbers. So there's words. Let me write some numbers. All right, so my example in numbers is 2.25 multiplied by 8.9. And the answer, if you do that multiplication, is 20025. So if there were no decimal places, if it was just 225 times 89, you would get 20,025. But these are decimals, so we need to analyze how many decimal places. So I'm going to use DP for decimal places. And there were two decimal places, 1, 2, in my first number. So DP is my decimal place. Just because I can't write decimal places all the way across and still have room for the number. So I'm abbreviating with DP. The second number had one decimal place. Decimal place was 1. I'm going to total those up. And that's where you get your 3 decimal places. You have to go from the back when you're doing the product, when you're figuring out the decimal places. So it's the how many decimal places on the right side of the decimal. So 3, and so we'll have to put the decimal 3 places over to get those 3 decimal places. All right, dividing. So this is the key information for dividing. In words, we still haven't gotten to the example problems yet. This is still key information. So in words, when you divide by a decimal, so you're dividing, the divisor is a decimal. The divisor is the one doing the dividing. If you can think about dividend and divisor, dividend sounds like a thing, divisor sounds like an action. It's a verb. So the divisor is the number that's doing the dividing, if you can't remember it any other way. And the dividend is the one that's getting divided. It's the thing that you're dividing up. So when you're dividing by a decimal, the divisor is a decimal, you're going to control the situation. You're going to have to make an adjustment with the divisor, and anytime you change the divisor, you're going to have to change the dividend also. And you're going to multiply them both by the same power of 10. And your whole point is to make the divisor an integer. So you're making the divisor an integer. Now, that's a lot of words, and that's a mouthful. But I bet when we look at it in numbers, you'll recognize exactly what all that's talking about. So write that down, and we'll think about what it all means when we look at the numbers. The numbers are probably more helpful in this case. So we've got words, and then we have numbers. So here's my numbers example. It's not the example problem, it's just the key information shown in numbers rather than only in words. I think you'll be able to understand the words better if you have both. So I'm going to use a green pen so I can move my decimal place. So my divisor, which is the number doing the dividing, is a decimal. So when you divide by a decimal, it says right here, I am dividing by a decimal, then I need to multiply both the divisor and the dividend by a power of 10 that will make the divisor an integer. So I want to make this 2.75 into 275. And the way I do that is I'm going to multiply by 100. so that I can move that decimal place 2 places. And then, but I can't just multiply the divisor, I've also got to multiply the dividend. So that's going to also move the decimal place 2 places. So now I've got a different looking problem, similar but different. I've actually got 275 dividing into 15,125. So I have almost a new division problem. If it helps you to, so write this out the way I've done it. Then when you go to do the problem, in practice, we usually just move that decimal over. We don't write the multiply by 100. We don't usually write that when we do the work. You can if you want to. And then we would just do long division. So now we have a regular long division problem. Sometimes this dividend will still have a decimal in it, which is fine. The one that cannot have a decimal is the divisor. So you had to change that one. All right, example 1. So I'm going to multiply 2 decimals, 4.3 and 2.5. So 5 times 3 is 15, 21, placeholder 0, 2 times 3 is 6, 2 times 4 is 8. Add down. So this is normal. 10. Normal multiplication. So just like we would multiply whole numbers. If you don't want to write the decimals in your original problem, if that confuses you, you can skip it, I guess, and multiply them as whole numbers and then go back. So I have 2 decimal places. Sorry, 1 decimal place for the first number. Getting ahead of myself. 1 decimal place and 1 more decimal place, which adds up to 2 decimal places. So I need 2 decimal places, so my answer is 10.75. So we've talked a little bit about checking your answer for reasonableness. And this is a really good place to practice that. So I'm going to look at my leading digits, which are the ones that are in front of the decimals, and I'm going to multiply those in my head. Usually when we have a small, we have just 1 digit each, you know your math facts enough to know that that's 8, but we've got some extra at the end, so it's kind of like checking for reasonableness with fractions. It should be more than 8, and it is. It's 10.75. The thing I'm really checking here is that decimal place. You know that by doing the multiplication between 4 and 2, if I had made a mistake on my decimal and gotten 107.5, I'd be way off, and I'd be able to tell immediately. Or 1.075, that's where most kids will make their mistake in placing the decimal. So that extra double check just to go back up, take a visual, look at your leading digits, multiply them in your head, and then you can check that 10 is reasonable. Example 2, I'm dividing by a decimal, so I'm dividing by 6.3, and whenever I have a decimal that's the divisor, I'm going to multiply enough times by 10 so that that changes into an integer. So this is 1 power of 10, multiply by 10, multiply by 10. So I'm going to rewrite. Now you can move your decimal like that. I'm going to rewrite it so it's not so sloppy. 6.63 now. I'm going to get rid of that point. 63 is going into 601.02. And when you divide that whole thing, you get 9.54. And now we're going to check for reasonableness. So I know that my original problem was 60 and some decimals, but 60 was the leading digit divided by 6. So that so that's 10, and 9.54 is close to 10. So I like my answer for checking that for reasonableness. It's about right. Seems reasonable. So example 3, not example 4, sorry. Example 3. So here's an example of 2 negative decimals. So I've got negative 4.2 and negative 2.7. I'm going to write them vertically. Negative 4.2 times negative 2.7. I don't have to worry about lining up my decimals with multiplication. That's an addition-subtraction rule. I do have to worry about how many decimal places, though. Decimal place is 1. Decimal place is 1. So my answer, I know, is going to have 2 decimal places. I'm going to multiply these like it was 42 times 27, and then I'm going to analyze my negatives. I'm going to use the same rules for decimals that I do for integers. When I have 2 negatives or 2 positives, the result is always positive when you're multiplying. So I know my result here is going to be positive. So I'm doing my multiplication and adding down 13 11, and then I need 2 decimal places. So 1, 2, so my answer is going to be 11.34. Positive, because I had 2 negatives. When I multiply 2 negatives, whether they're decimals, fractions, or integers, I get a positive product. Here we have a division problem that also has a negative. So let's do this one. Example 4, 2.1 divided by negative 0.24. First thing I'm going to do is write this as a long division problem. And my divisor is the negative number, the 0.24. So that's going to go on the outside of my long division box. And the dividend is 2.1. So the dividend is 2.1. The divisor, the one doing the dividing, is negative 0.24. So next thing I want to do is multiply by 100, both the divisor and the dividend, so that I can turn that negative 0.24 into an integer, which is going to be negative 24. And then I'm going to move the decimal place. And I have to add a 0 as a placeholder because I don't have enough room. I don't have enough digits to the right to move my decimal place 2 places. When I multiply by 2.1 by 100, I'm going to get 210. And since I have my divisor is a negative, but my dividend is a positive, when I have one sign different from the other and I'm dividing, my result is going to be negative. So I know, and my answer already is going to be negative, so I'm going to put a negative sign up there, and I'm going to figure out how many times 24 goes into 210, and I'm going to try 8. So that's 8 times 4 is 32, 16, 17, 18, 192. Subtracting down, I get 18, and 24 doesn't go into 18, so I have to add a 0, bring that down. And when I added the 0, I needed to go up here and put a decimal place. Yikes. A lump, not a decimal place. And 24 goes into 187 times. That's 28. 16. Use subtraction. Bring down the 0. And 2 goes into 12 6 times, but the 4 is there, so I'm going to guess 5. And that's 20, yeah, 120, no remainder. So negative 8.75. All right, so your 4 practice problems: 2 multiplication, 1 with a negative, 1 without, and 2 division, 1 with a negative and 1 without. 7.8 times 2.6, I'm using an X as my multiplication symbol because when I use a dot, like the book does, and I have decimals, I think it's confusing. So I'm using an X. I'll probably move toward using, there's another way to write this, which I prefer is more algebraic. This is more the algebra way that you would write it. Because in algebra, we get X becomes our variable, so we get away from using X as multiplication. So I wrote it both ways here for you. Negative 8.2 times 0.7, 13.2 divided by 11, and negative 8 divided by negative 3.2. And then don't forget your wrap up. Bye for now.